Okay, this is the second lesson of the week, determining a definite integral using substitution. So the catch is here is that we're going to have to use a u, because we're going to use substitution to do it. I'm going to do a and b and e and f. If you want to fill in c and d, I'm going to have the filled in notes in the classroom, and you can go look at them. They're all done and they're filled in. So if you want to fill in C and D, go to the classroom and use the filled in notes. But for this podcast, I'm just going to do A, B, E, and F. Okay? So, determine the definite integral. Well, we can't go right to filling in 0 and 2 because we can't do the antiderivative of x and the square root of 4 minus x squared because you have to do substitution first. Okay? So, I'm going to have to do substitution, and I'm going to make u be 4 minus x squared. I'm going to write it up here, and I'm going to show you why. So I'm going to make my u be 4 minus x squared. And I'm going to write it up there, and you'll see why in a second. So here I'm going to do my normal steps. U equals 4 minus x squared. And then du over dx, or du, I have to find the derivative, just like we had to do. That's why I made you practice so many last week. Derivative of 4 is nothing. Derivative of negative x squared is negative 2x dx. Then I look to see what I need to replace. I need to just replace an x and a dx, right? Because this middle place is going to get replaced with a u. Okay, so I'm going to have to divide that negative 2 over. This is why practicing those substitutions that I gave you last week were so important. So I'm going to get negative a half du equals dx. X dx, sorry. So we replace like we did before. We're going to get not 0 to 2. I'll show you why that in a second. So the x dx gets replaced with negative a half du. So I'm going to get negative a half and then du at the back. And then this square root 4x squared becomes the square root of u. And the square root of u is just u to the half. So I'm going to write that. Okay? So that's all the same. Everything's the same. The catch is I can't put from 0 to 2 because, and this is where you guys are going to make mistakes, you can't go from 0 to 2 because 0 to 2 gets filled in for x's. Do I have x's anymore? No. So here's the extra step, and that's why I wrote the u up here. I need to find out what this 0 and 2 is in u's. Okay? So I'm going to do the top part of the integral first. I'm going to fill in the 2. So I'm going to go u equals 4 minus 2 squared, which is 0. So I'm going to get a 0 at the top of this integral because when I filled in the 2 from the top, I got 0 for u. Now I'm going to do the bottom one from the integral, which is a 0. I'm going to use this 0 down here, right here. So I'm going to go u equals 4 minus 0 squared, which is 4. So that's going to go on the bottom. So that's the only extra step you have. You have to find the new numbers to go on your integral symbol, filling them into the u. That's it. That's the extra step. Now we're just going to use the fundamental theorem of calculus. That's it. So it's all the same steps, but you need to remember to find out those numbers. Now some of you may freak out and say, wait a second, Lepp, you told us that the top number needs to be bigger than the bottom. It does, except for in u substitution. So in u substitution, you find the top number, you fill in the 2, and I got a 0, so I put it in the top. I replaced the top 2 with a 0 because that's what I got when I filled it in for u. I replaced the bottom 0 with a 4 because that's what I filled it in for u. So only for u substitution and only for u substitution can the top number on the integral be smaller than the bottom. I know in the assignment last week that one of the numbers on the top was smaller than the bottom. That was a bonus question. You have to be able to take a negative 1 out to flip those numbers. And I'm going to show that to you next week. But I didn't want to show it to you to mess up substitution rule. Okay? Because substitution rule, you plug in your u of the top, put it in the top, plug in your u of the bottom, that for that x, in for x, and get the u for the bottom. And you put them the way they are. And if the top is smaller than the bottom, absolutely okay. Now we're going to do fundamental theorem of calculus like we've done the whole time. Okay? So what do? We plug the 0. Oh, we do the antiderivative. So the integral. So I go u to the half. I add 1 to it, so it becomes u to the 3 halves, right? In front I have, I'm going to leave a little more space actually, sorry. So I have u to the 3 halves. In the front I have negative a half. Then I'm going to divide by 3 halves this negative a half, but dividing by 3 halves is the same as multiplying by 2/3. So I'm just going to put the 2/3 in front. Plus c from 4 to 0. And like I said, only in U substitution can that top number be smaller than the bottom. And I will go over example 4D next week to not confuse you, okay? But for U substitution, the top can be smaller than the bottom, for example, in this case. So now I get, the 2's cancel, negative 1/3 u to the 3 halves plus c from 0 to 4. Now I plug it in. Negative 1/3 times 0 to the 3 halves plus c minus negative 1/3 times 4 to the 3 halves plus c. Okay, so I'm going to get 0 plus c plus 4 to the 3 halves is the square root of 4 cubed. Square root of 4 cubed is 2 to the 3, which is 8. So I'm going to get 8 times negative 1/3, so negative 8/3. And I don't have a plus sign in between. I'm going to go like that. I'm going to go like this. So I have minus, and then I get negative 8/3 plus c. So I actually get 0 plus c plus 8/3 minus c. The c's cancel, and I get 8/3, which the area under the curve of x square root 4 minus x squared from 0 to 2 is 8/3. And if you look at the graph, if you typed x square root 4 minus x squared into your calculator, into your y equals, and you looked at the graph from x equals 0 to 2, you're going to see it's above the x-axis, and that area underneath is approximately 8/3. Okay? I also told you that you can type these into your calculator to check them, right? If you just gave me answers, I'm going to give you no marks because that means you didn't do them. But you should be able to walk away from these assignments knowing if you got them right or not, because you can just go math, and then you can arrow down to FN integral, and then you hit enter if you have the newer calculators, and you can literally type it in 0 to x square root 4 minus x squared d. It gives you, and you put an x in it. You can type it in just exactly like it looks. Hit enter, and it'll tell you 8/3. It'll tell you a decimal, and then you can go math, enter, enter, and you get 8/3. So you can check these, right, with your calculator. However, if you just give me 8/3 as an answer and no work, I'm not giving you any marks because you just used your calculator. But I want you to know that you can, so you can check them. Then you can hand in your assignment knowing you got it 100% correct, or no, you need to go back, or no, you need to ask me to talk to me and I can help you. Remember, we can meet on Google Hangout Meets and I can help you, or you can email me and I can try and help you that way. So don't flounder, ask for help, all right? But you should know if you got them right or not. Okay, then we're going to do B next. And then remember I said E and F. If you want C and D, you have to go to the filled in notes and you can look at it. Okay, for B, we have 1 minus cos 2 theta over 2, right? Okay, I'm going to rewrite that immediately with a half in front. So I'm going to go from 0 to pi over 2. And I'm going to write it as a half times 1 minus cos 2 theta d theta. Why would I do that? Because I can take the half out front. Remember, whenever you have just a coefficient, you can bring it out of your integral and make your life a heck of a lot better. So it equals 0 to pi over 2, 1 minus cos 2 theta d theta. Now, when you have a trig, I always say to try first, to make u be that, whatever's in the brackets. So if it's not just a theta, if it's just a theta, you can just do normal integrals. If it's 2 theta, 4 theta, whatever, you can make that be your u. So I'm going to write that up here. U equals 2 theta. Then over here I'm going to do the actual math. Because remember, I need this to split to get my new numbers on my integral when I have u's. Okay, so my u equals 2 theta. My du equals 2 d theta. Well, I don't need to replace anything but d theta, right? I need this to go away. So I can make it be 1/2 du equals d theta. So I'm going to fill in what I know. So I'm going to go 1/2. I am not going to fill in the numbers because I need to go up here at the very top and figure them out. And then I can go 1 minus cos of u, and I can do the antiderivative of that very easily. And then d theta turns into 1/2 du. But I never write the 1/2 there. I'm going to write it in front. Now wait, it's a coefficient. It can come out and join the 1/2, which I can do in the next step. So I can have 1/4 1 minus cos u du. My issue is I have no numbers on this integral symbol. It's just been going along. I cannot go 0 and pi over 2 because 0 and pi over 2 get filled in for theta. I no longer have a theta, I have a u. So I need to fill pi over 2 into u, 2 theta, and find out what my new top of my integral number will be. So I go u 2 times pi over 2. I fill my top number in. It's pi over 2. And I get pi. So my new number on the top is pi. So it's going to be pi here, and it's going to be pi here. So it has to follow down. And then I need to find my bottom one, which used to be 0. It was 0 here. I need to fill it in and find out what it's going to be. So u 2 times 0. Oh, it's still 0. Okay, so the bottom is zeros. And now I can just do my integrals like I did before. So I have 1/4 sitting in front, and then I use my fundamental theorem of calculus. And then when I figure that out, I multiply it by 1/4. So what's the antiderivative of 1? Well, it's 1 theta. Right? Constants always become just the variable. And then the antiderivative of minus cos is minus sine. Because the derivative of sine is cos, so the derivative of negative sine is negative cos. And remember, we're going backwards. So sine of u plus c from 0 to pi. And now we just do the fundamental theorem of calculus. So the quarter sits out front, and we're going to fill pi in first. So pi minus sine pi plus c. Minus, and fill in 0. 0 minus sine of 0. Now remember, sine 0, cos 0, they don't always result in 0, so you have to fill them in, unlike 0 squared, which would be 0. So you need to fill them in and see if they result something, because like cos of 0 is 1, right? All right, so the quarter sits out front. Pi is pi. Sine of pi is 0. So minus 0 plus c. Minus 0. Now sine of 0 is 0, so I'm going to minus a minus 0. So I'm going to get plus 0 minus c. C's cancel. All the zeros cancel. So I'm going to get 1/4 times pi technically, which is pi over 4. So if I typed my original, which was 1 minus cos 2 theta divided by 2 into my y equals, and I looked at the graph from 0 to pi over 2, the area under there to the x-axis would be an area of pi over 4. Okay? So I'm skipping C and D, but if you want them, you can go to your notes. We're going to do E and F. I just wanted to give you an example of the different types. So this one is from area under the curve from 2 to 3 of the graph of, this would technically be a 1 up here, 1 over x ln x squared dx. So this can be rewritten technically as 2 to 3, 1 over x ln x squared dx. So I'm going to try the ln x first as my u because it's in a squared and that seems to be my issue. Remember, you could try u's, and if they're wrong, if you can't get rid of everything else, all the x's, then try a different u, no big deal. So u equals ln x. I'm going to write it up here so that I can find my new u's. And I'm going to write it over here so I can do my normal u substitution. So u equals ln x. So du, the derivative of ln x is 1 over x dx. Remember, you take what's beside the ln, put it on the bottom, and the derivative of it on top. And I'm technically replacing 1 over x dx. So this is good. I'm going to replace that with du. So in my next step, I'm going to get not from 2 to 3, so I'm not going to fill it in right now. 1 over x dx becomes du. So I'm going to put that at the back. Ln x squared becomes u squared. And then I'm going to put a 1 on the top because there's nothing left. But I need to find my new u's. So what are my new u's? Well, I'm going to plug in 3 and I'm going to plug in 2. 3, whatever I plug in for 3 stays on the top. Whatever I plug in for 2 stays on the bottom. So on the top, I'm going to get, that's messy, u equals ln of 3. So I get ln 3. And then here I'm going to get u equals ln of 2. So I get ln 2 on the bottom. Oof, that's messy. So now the 2 on the bottom is ln 2. And then I can do the integral fundamental theorem calculus on that. I'm actually going to rewrite it because the easier way to do an integral is to raise that u up. So u2 on the bottom is the same as u to the negative 2 du. And that's easier for me to do an integral of. So u to the negative 2, if I add 1 to it, I'm going to get negative 1. So I'm technically going to get u to the negative 1, or 1u to the negative 1. And then divide by negative 1 plus c from ln 3 to ln 2. So that's the same as negative 1 u to the negative 1 plus c from ln 3 to ln 2. Oops. All right, now I have to do the fundamental theorem of calculus by filling that 3 and that 2 in. So I'm going to get negative 1, and then I'm going to get ln 3 to the negative 1 plus c minus negative 1 ln 2 to the negative 1 plus c. And so I'm going to get negative 1 over ln 3, because I can just drop that to the bottom and make it positive, plus c, minus a minus 1, so plus 1 over ln 2 minus c. C's cancel, and my answer is negative 1 over ln 3 plus 1 over ln 2. And how do I know I'm right? Well, I just type that into my calculator and get a decimal. The decimal is approximately, that doesn't look like approximately at all, approximately 0.53245, etc. So when I type that in, I get that as my decimal. And then I go to math, and I go down to ln fung, the fn integral one. And I type in 2 to the 3, 1 over x ln x squared times dx. And it'll give me that same decimal. And I know I'm right, and I move on. Okay, last one. So now I'm going from 0 to pi, e to the negative x, cos e to the negative x. And remember when I had a trig and I don't have an x beside it, I immediately try and make that be my u. So I'm going to put it up here so I get my new u's for my integral symbol. So I'm going to go over here and do my actual math. U equals e to the negative x. Du equals, remember you take the derivative of the exponent, rewrite it, and then ln of e. And I need to replace ex dx, not negative 1 ex dx. So I'm going to divide by the negative 1. So I get negative du, or negative 1 du, equals e to the negative x dx. Okay, so I'm going to get my little integral symbol with no numbers on it because I'm going to change to u's, and I can't use the 0 and pi because that's for x's. So e to the negative x dx is negative 1 du. And in the middle, I'm going to have cos of u. What can I do with that little negative 1? Because it's a coefficient, I can bring it out front. And so I'm going to have cos u du. But I need to figure out what the heck to put on my integral. So I'm going to plug my two x values into my new u. So I'm going to plug in pi for my top one. So I'm going to get u equals e to the negative pi. So that's the top, which is kind of crazy. And then I'm going to plug in 0. So I'm going to get u equals e to the negative 0, which is e to the 0, and e to the power of 0 is 1. So I'm going to have a 1 on the bottom of each of mine. E to the negative pi is my top, and 1 is my bottom. And then I'm just going to do my fundamental theorem of calculus. The black. So I have negative 1 square bracket. The antiderivative of cos u is sine u, because sine u, the derivative of sine u is cos u. So the antiderivative of cos u is sine u. Sine of u plus c from 1 e to the negative pi. I know that sounds weird. I need equal signs. And then I'm going to get negative 1 and do my fundamental theorem of calculus. So sine e to the negative pi, which is kind of crazy, plus c minus sine of 1 plus c. Okay, so I'm going to get negative 1 sine e to the negative pi plus c minus sine of 1 minus c. C's cancel. The negative sign distributes, the negative 1 distributes through, so I'm going to get negative sine e to the negative pi plus sine of 1. And you can leave it there because none of those are on the unit circle. Or you can say approximately 0.79827. So that's the area under the curve from 0 to pi of e to the negative x cos e to the negative x dx. Okay, so that's the area under the curve from 0 to pi. And you can type that in and check it out. And that's it. So with u substitution, the big thing I need to send home with you is that the top number can be smaller than the bottom once you find your new u. And you cannot put the same numbers on the original integral on your u integral. You need to find it, like I did for every single question. You need to find your new numbers. And that's your lessons for this week. Quite short and sweet. Hope you have a great day. I miss you all.